going to finish up chapter 2 right now. Hopefully we'll get through everything in two different videos here. Last time we had gone through uncertainty. We had started discussing significant figures. We talked about how to actually do measurements. And this time we're going to go through the rules for significant figures. All right. So the number of digits recorded in a measurement gives an indication of the reliability of that instrument. And again, if you way over record digits, then you're sort of lying. All right. And we don't want to do that. All right. So the result of any calculations must not imply a greater reliability in the data. And sometimes data is written with uncertainty explicitly indicated. You get this plus or minus mark that you have here. This is the more modern way of doing science. This is also what is typically written on engineering drawings if you end up going into engineering or something like that. And that's okay. It is still, in my opinion, easier to describe sig figs the way this is, and it gives you just a fine idea on how to do this. And this is the way most lab books go as well. So, we're just going to stick with sig figs in the normal way. So when you're doing a digital instrument, it's a little bit easier on you. And more instruments are digital anyway. So this is helping. It doesn't get away from the fact that you still have sig figs that come out of that, and you need to properly record and use those in calculations. But for a digital instrument, you just record the numbers that are written on there, and they're all significant, and you don't have to think at all about, am I estimating between the numbers and all that kind of stuff. It's all the work's kind of done for you there. But anyway, it's still giving you a certain number of significant figures from that measurement. Okay, another note about uncertainty is sometimes the uncertainty in an experiment is so high, like you can think the error bars are so high that it really clouds the meaning, it confuses the meaning of the experiment or the underlying physical phenomenon. So you can think that would be a bad thing for, intro chem students to be utterly confused about the meaning of an experiment because the uncertainty in there takes away the trend or whatever it is. But also, sometimes it can cloud the underlying physical phenomenon. So sometimes we have to come up with better instruments to measure things so that we can actually understand the underlying physical phenomenon. And I'm not going to go through this example here. I'm going to move on. Measurements continued. I'm not sure why I had this slide here, but at this point in class, a lot of times I'll do an in-class exercise where I hand out rulers and people get to measure something, and then we look at the numbers that the students got off of that. And you can see you get widely varying numbers and number of sig figs coming from different students. So I can't do that here, but also, sometimes students would be uncomfortable with doing that, and the intent was not to embarrass anybody, but it's just kind of interesting. And one thing to note on any recording device is, if you want to get a better answer, like maybe you could zoom in, but then when you zoom in, you see, right, this is the line, let's say it's for, 8.3 centimeters or something, right? This is the line for 0.3, but where on this line is exactly 0.3? When you zoom in enough, you can see the thing actually, it's not a point line, right? It's actually written with something that had some degree of uncertainty in the actual line itself. So there's just a limit for instruments on the level of certainty, and some inherent uncertainty in all of them. So I like that illustration. It's interesting for me. All right. So here are the significant figure rules. We're going to go through each of these in turn. We'll talk about them, give you a little bit of practice to look at them. You need to do some homework to get some practice with working with these on your own. And let me just run through them now, and then I'll go through each of them specifically later. So all non-zero digits are assumed to be significant. So somebody did a measurement, all right, and they give you their measurement. First off, you can assume that they properly recorded from that instrument. That's the assumption that you have to make. If I give you a number on a test or a quiz or something, you assume that it's properly recorded. And then how do you determine the number of sig figs? Well, all non-zero digits are automatically significant. Okay? In that case, zeros are different. And zeros present us with a little bit of a problem. They may be significant. Okay, so we're going to have some additional sub-rules on there to deal with zeros. Exact numbers are infinitely significant. What is an exact number? We'll get into that in a little bit. And then for addition and subtraction, we have some rules on how to do operations with sig figs. For addition and subtraction, it's the same rule. And then for multiplication and division, you have the same rule. Okay, they're different than each other though. Okay, so let me just go ahead and go through each of these in turn. So zeros are special. So skipping over the first one, right? Non-zero numbers are always significant. But getting to zeros. So zeros are special because sometimes we replace digits that are not significant with zeros, rounding. All right. If I told you, hey, you see across that field, it's about 100 yards. All right. What level of certainty do you think is in my, hey, it's about 100 yards? Are those zeros significant that I just told you? So if I wrote it down, right, it would be like this. Are these zeros significant in that number? In this case, no. I've sort of rounded this off. It was a guesstimate to begin with. So we need some way to deal with zeros which is coherent. And for the first thing, interior zeros are not a problem. Okay, interior zeros are always significant. So if they're between two non-zero numbers, then they are significant. Okay, some easy to stand on there. So these zeros had to be part of the measurement because there's another number on the other side here. You know, I didn't say, hey, it's about 1,000, centimeters or whatever. I said 1,001. So that was part of my measurement. They weren't part of a rounding operation. So here's the rules for the other types of zeros, leading or trailing zeros. If I have a leading zero, okay, whether I have a decimal or not, if I have a leading zero, that is not significant. Leading means to the left of the first non-zero digit. All right, so this number right here has two significant digits. That's what we're trying to determine here. It's the number of sig figs. Leading zeros give us the same information as a metric system prefix, which we're going to get into later. In this case, instead of writing 0.0017, I could have just written 1.7 milliliters, and that would still have the correct number of sig figs. So I just eliminated those zeros by adding a prefix. Okay. All right. The other side, if I have trailing zeros, if I have a decimal, are always significant. Okay. So if I have this number 2.10, then that zero needed to be there. They recorded it on purpose. So that was part of the measurement. And same thing with 10.00, right? I'm not sure how you would find something that's exactly 10.00 centimeters, but they did. All right, this was part of the measurement. So this should make sense because when we round decimal places less than 1, we drop the digits rather than replace it with 0. Okay, next thing, if I have trailing zeros without a decimal, then this is a problem. All right, so you should never record numbers this way. Trailing zeros without a decimal are ambiguous and they're not correct. So you don't do it. Now, if you get these from somebody, then you are perfectly within your rights to cry foul. There's a problem here. So if I did this on a test, you could say it's ambiguous. I can't determine the number of sig figs. And you don't want to do this. And how are we going to get rid of these zeros? We're going to go to scientific notation. Okay. So these were rounded or, just estimated or something like that. Okay. So how many significant figures do each of these digits have? These numbers have? You can pause now and think about it. I'm just going to go through it. For this number, remember, leading zeros are not significant. Okay, so we can ignore these for sig figs. All non-zero digits are always significant, and then interior zeros are significant, so this 0 is significant. And then trailing zeros with a decimal are significant. So this number right here has 4 sig figs. Okay, this one, don't let the large number of zeros fool you. It just has 2 sig figs over here, the 6 and the 0. This 0 is because it's after the last non-zero digit. This one, there's no decimal, but that doesn't matter for interior zeros between non-zero digits. So this one has 6 significant figures. If we don't have zeros at the end, then I don't need to worry about putting a decimal here. Okay? And then this number, right, these are not significant. You have 3. Okay? There are the answers written out for you. So they were asking which zeros. I marked the significant zeros in red. All right, what do we mean by exact numbers? Exact numbers happen a lot of times with definitions. And when we get to calculations, this is where this becomes important. When I have exact numbers, I do not want to let this definition limit the number of significant figures that I have coming out of a calculation. So what does that mean? Well, let's say I used this for a conversion between something, right? 1 minute is 60 seconds. Well, the number of sig figs is important when I'm looking at these calculations. So you might think that this is, first of all, ambiguous as to how many sig figs it has, and you might think also that it just has 1 sig fig because I just have that 6 there, or conversely, the 1 digit there. And this is not the way you want to think about definitions or exact numbers. This has infinite significance, meaning you do not want to let it limit the number of sig figs coming out of a calculation. That'll make more sense when we get to doing significant figures calculations with, like, say, multiplication and addition and such. Okay, and then exact numbers are not considered when determining where to round. That's what I'm talking about, right? We don't consider these when we determine where to round it. Okay, that's exact numbers. Definitions, certain things like that. You're not going to let them limit the number of significant figures for your calculations. Okay. Not all conversion factors are exact, so sometimes you'll have numbers such as kilometer to mile conversion. Right? They give you 0.6214. This is not an infinitely significant number because we're converting between 2 different unit systems. It's not a definition, right? This is a conversion between these 2 differing sets of units. Okay. I am not terribly concerned. I'm going to give you conversion factors. If something's a definition versus a conversion factor, you should usually be able to tell. And again, I'm not focusing on that for the course overall. All right, let's talk about how to do addition and subtraction and multiplication and division. When we are doing addition, and the same rules apply for subtraction, so it's going to look exactly the same, we need to look at the smallest number of decimal places. Okay, that is what's important for determining where to round after a addition and subtraction. So for this one, I have this number, it has 1 decimal place, this one has 3, this one has 1, this one has 2. So in my final answer, I'm going to round to that first decimal place. So you do the problem like normal, and then you round it to the first decimal place. All right. The easiest way to do this is to set it up just like you remember doing in grade school. So you line it all up. Oh, doggone, I don't have one. You line it up where you line up the decimal places, right? So you put the tenths all in a column and the hundredths all in a column, and then you just kind of draw a line on the smallest number, right? Whichever one has the fewest number. In this case, 2 of the numbers just have 1 digit there. So you did this in your calculator or something, it's going to give you this number. Again, your calculator is not telling you how many sig figs are in it, and you would have to know to round this to the first one. We use the same rounding rules that you're probably used to. If the number to the right of it, if I'm going to round it here, the number to the right of it is 5 or larger, so I round this up. Okay, if this number right here had been a 4 or less, then we would have left it as is. So use the same rounding rules that you're probably used to. Okay, so those apply for addition and subtraction. Now let's talk about multiplication and division. All right, multiplication and division, you just need to look at which number has the fewest number of significant figures, and you're going to round the answer to that number of significant figures. So it's different than addition and subtraction. You're just looking at the overall number of sig figs. With addition and subtraction, weird things can happen with the total number of significant figures. So addition and subtraction and multiplication and division are different. So here I have three numbers. This one has 2 sig figs. This number has 3 sig figs. This number has 3 sig figs. So again, for these rules, you need to know how to determine the number of sig figs first. That is a necessary requirement for doing these operations. And just by the way, you're going to be expected to do all calculations to the proper number of sig figs for the rest of the course. All right, this just carries on for the entire course. So here we have 2 sig figs. That's going to limit our number of significant digits in the answer. So you plug all this into a calculator, you get a number, and it could be 15 digits long. You have to know how to find the number of sig figs here, and then know which number to round to on the calculator. All right. So let's see. You get this number coming out of your calculator. You look here and you say, hey, I need just 2 because I'm limited to 2 on the initial numbers. So I'm going to limit it and round it at this 3. Again, the 8 is to the right of it. The 8 is larger than 5. Sorry, it's 5 or larger, and so we round this to 4, and then we're left with 2 sig figs in the answer. Okay. All right. A quick note here. If you're doing a multi-step problem, then these rounding operations, you don't want to do them until the end, but you still need to know where the last significant digit is. And so in order to eliminate rounding errors, we mark whichever was the last significant digit. So the way you would do that is you would come here and underline this 3 on your page, and that lets you know that that's the last significant digit. Excuse me, guys. Turn my ringer off. So you have a mark here, and that lets you know for any future operations, this number only had 2 sig figs, or it was limited to this decimal place. Okay. All right. So here's an example for you. Johnny measured a graduated cylinder that was 3.2 milliliters. Measured from a graduated cylinder 3.2 milliliters of solution with the correct number of significant figures. He sees the next step that he needs the solution in liters, so he's going to convert that to liters. And the way you get liters from milliliters is you just divide by 1,000, okay? And that's an exact number, that's a definition, and so we just move that decimal point over 3 places, 1, 2, 3. How many significant figures do I have on this number? Okay. Hopefully you can see I still just have 2 sig figs. Okay. What about my next problem? Johnny completes an experiment and measures 3.2 liters of solution with the correct number of sig figs. So he measured it correctly. For some calculations, the next step he sees he needs the solution in milliliters, and so he converts it to milliliters by moving the decimal place over at liters to milliliters. You just multiply by 1,000, so he's moved the decimal place over 3 times. How many sig figs does he have now? Well, poor Johnny, he has accidentally just kept this decimal place in here rather than going to scientific notation. How is he going to write this with proper sig figs without it being ambiguous unless he goes to scientific notation? Right? It's going to be a problem for him and for you, right? Unless you just get used to thinking in terms of sig figs and converting it into scientific notation if needed. I still should only have 2 sig figs, but the way he's written it here is he has, right, all of these become significant zeros because he has trailing zeros with a decimal. So it looks like 5, but it should be just 2. Okay. The correct way to write that would be like this. Okay. Let's see. Make that easier for you. How to identify the significant figures in a given number? You need to know how to do that. You need to be able to do multiplication and division, and addition, subtraction. You need to know how to record the significant figures from an instrument to the correct number of sig figs. And remember, your calculator just throws all of the digits back at you, and you need to know how to record properly or determine where to round. And then rounding errors can introduce additional error. If I had time, we could go through an example of how you can drastically change your answer with rounding errors. But I'm just going to go ahead and leave that there. And I give you some examples to work, and they'll tell you how to do that. But again, remember, do your homework. And I'm going to have to end it. Already kind of gone over a little bit here. So we'll have to have a chapter 2, part 2. That'll be part 3. Okay? All right. Have a good one.